We conclude this series of screencasts on fruitful methods by examining how we would define our own fruitful method and how such a definition would be handled by the Java execution model. So let's start with our stair bugle that we've seen before that can be used to build a step of a certain stair size. This is something we saw in a previous screencast. And notice how this method is a void method. The keyword void here means that build step does not return anything when it is invoked. That is, invoking build step acts like a statement. But suppose we want to change build step. Suppose we want it to be the case that after the bugle goes off and builds a step, that at the very end it should actually return its final position. And then that final position could be used by, say, some other bugle to move there or something like that. So what would we need to do to change the definition so that build step now returns a value? And we will call methods that return a value fruitful methods because they're bearing fruit. So there's two things that we need to do in order to change build step from a void or non-fruitful method into being a non-void or fruitful method. One is we have to specify what the return type of the method is. So over here, rather than specifying the keyword void, we need to specify a type, which is the type of the value that will be returned. So in this case, the type that we want to return is a location. And so we would put location here. The next thing we have to do is at the point when we're done with our building of the step and we want to return the position of the bugle, we actually have to say, hey, this is the spot at which we want to give back a value. And the way we give back a value in Java is to use something called the return statement. So return is a keyword, and return means we want to return a value at this point. And the thing that we want to return is the result of this get position. So get position would return the position of the bugle at its final position, say over here. Then this expression would denote that position. And return says, take that position and throw it back to whoever called build step. So one way to think of this is that when you invoke a fruitful method, you are setting up a catcher in a pitcher-catcher combo, and that what return does is return is the pitcher, and the pitcher throws the value back to the catcher that's waiting for it. That's one way to think about it. Okay, so here's the way we would write it in normal Java. Again, return type location, and then the return statement says at the end, the value we want to return is the position of the bugle at that point. So now let's take a look at an example. We're going to have two stair bugles in this example called Jack and Jill, and they're going to walk up the hill together making this pattern. So here we have a stair world, and we have two stair bugles, Jack and Jill. We're going to distinguish them. Jack is going to be the default red, but we're going to set Jill's color to blue. And then we have the same build stair method that we just looked at. That's the fruitful one. That is, it returns a location by returning the final position of the bugle after it returns the stair. Okay. Now, in order to create this particular pattern that we see on the right here, what we're going to do is we're going to have Jack and Jill go back and forth. So after we set Jill's color to blue, notice that we have Jack, who's the red bugle. He's going to build a stair of size 4. So he builds this stair over here of size 4, and at the end, he returns his position, which is this position. And then we set Jill, who's the blue bugle, we set her to start at that position. And then Jill is going to build a stair of size 2. So she builds this stair here. And then Jill will end up in this position. And then we'll have Jack set his position there. And they'll continue by alternating up and down the hill in order to create that pattern. So now we'd like to see how the Java execution model can explain how all of this works. So we begin in the usual spot here. within the execution frame for the run method, where we are in our stair world. And the first thing we're going to do is create a new stair bugle named Jack, and then in object land we'll get a stair bugle SB1, and it will be named Jack in execution land. We'll then create another stair bugle called Jill. So stair bugle SB2 will be created in object land, and it will be denoted by the variable Jill in our execution frame. We will set Jill's color to blue. So Jill is now blue. And now let's see what happens in one of these complicated statements where we call set position and build stair in the same spot. So here we have a statement. So Jill.setPosition is a statement, and we start to evaluate the parts of the statement. First, we have to understand who is Jill, and the way we understand who is Jill is by looking at our variables in our current execution frame, and we find that Jill is SB2. The next thing we have to figure out is who is Jack, and the Jack in our execution frame, that variable is SB1. And now we want to eventually invoke SB2 set position on some position, but we don't know what the position is yet. We have a sub-expression, which is the SB1 build stair. This sub-expression right here, that denotes a location. We have to figure out what location that denotes. And the way we're going to figure out the location that denotes is we use the Java execution model. So here we have the invocation of a method. It's a non-primitive method. It was defined by us. So in the Java execution model, for any invocation of a non-primitive method, we are going to create a frame. So we create a frame, and that frame, as usual, is going to have a variable this, which names the receiver, in this case SB1, and it's also going to have variables for every parameter. In this case, there's one parameter stair size. This is the same kind of build stair that we've studied before. And so we expect that the first 4 statements should execute as we've seen before, and that this bugle, which is our red bugle named Jack, should go off and build the stair of size 4. The interesting thing happens in the 5th statement here. So what happens now? So at the very end, we have a return statement, and the return statement is followed by an expression. It's followed by this expression, and we have to evaluate this expression. So first we have to evaluate this, and the value of this is SB1. And now we evaluate SB1.getPosition. Well, as we've seen previously, SB1.getPosition denotes what's in the position instance variable of SB1. So it denotes this value here, which is the location 44. So that expression gets replaced by the location 44. Now, in this particular case, we decided not to show location objects explicitly. We could have. For instance, if we had up here, you can imagine that we have some location object. Let's say it's L17, and we could have had L17 denoting a location whose x-coordinate is 4 and whose y-coordinate is 4. And in that case, rather than having this here, we would have had L17. And then down over here, rather than returning 44, we would have returned L17. So this notation 44 is just an abbreviation for a location that actually exists in object land. Okay, now the interesting part is when we execute this return statement, it sends the value 44 back to the spot where our fruitful method invocation was. So our fruitful method invocation here, SB build stair of 4, was over here. That expression for the fruitful method invocation is replaced by the value that is returned by the return. So again, think of the build stair invocation over here as being a catcher that's waiting for a value, and think of return as being the pitcher that's pitching the value back to the catcher that's waiting for it. So that is how the return is accomplished. And so when the return is performed, the entire fruitful method invocation is replaced by the location 44. And now we can continue with our original goal, which was to change SB2's position. And we now know the position we want to change it to is 4, 4. So now when we execute that, we see that the position has changed to 4, 4. Oops. It's changed to 4, 4. Okay, now we can continue. So now we're going to alternate. Now Jack is going to set his position to be the position of Jill after she's built a stair of size 2. So we need to figure out who Jack and Jill are. Jack is SB1, Jill is SB2. We're going to have SB2, who is Jill, build a stair of size 2. Building a stair requires creating an execution frame. So all this executes as before. Jill has now built her stair of size 2. We can see that up here. You can see up here she's built her stair of size 2. And she is going to return her final position, which is 5, 5. So that final position goes back from the point of return, which is over here, and it goes back to the point of call, the point of invocation. So the invocation for Jill build stair 2 is now replaced by 5, 5. And now we set SB1's position to 5, 5, and we continue. So this keeps on going back and forth. We now have Jack build a stair of size 3, invokes a frame. We have Jill set her position to that spot. We now have Jack set his position to Jill after she builds a stair of size 3, build a new frame. That means that that Jill will go to 9, 9, and Jack will set his position to 9, 9. And by the way, up here, the reason we don't see Jack, so even though Jack is at 9, 9 here, the reason we don't see him is that both Jack and Jill are at the same position. And since Jill was created later, she shows at the top. So it turns out that Jack is red at that position. He's just underneath Jill at this point. Okay, and continuing, we now have a stair of size 2 that Jill builds, and Jack builds, and then Jill goes to that position, and finally we have Jill build the final stair of size 5, and Jack goes to the position at the end. And so both of them end up at position 13, 13. And so what we've seen is we have now seen how to understand fruitful methods, not only primitive ones like get position or get color, but also we've seen how to define our own ones like the fruitful version of build stair. And we see that the Java execution model can completely explain what it means to return a value from a fruitful method.